Hello, my name's David Cardwell. I'm Professor of Superconducting Engineering at the University of Cambridge. I'm also Pro-Vice Chancellor with responsibility for strategy and planning, also at the University of Cambridge. It's my pleasure to speak to you today, mainly about innovation. And I want to talk to you about innovation within the context of educational development, starting at school, how that may progress through obviously further and then higher education, what the key elements are of good innovators and what you can learn along the way, and what you should aspire to. I'll also talk about where I think some of the potential difficulties lie and some of the misapprehensions about what research and innovation means. So I should say I've been leading a big research group now for more than 30 years. My field is high temperature superconductivity. It's extremely exciting. I've been fortunate, but trying to share some elements of that experience with you, hopefully, may help you decide if it's the kind of thing that you want to do. And of course, not everybody wants to be an innovator, nor should you want to be an innovator. But if you have a flair for it, if you have an inquiring mind, and if kind of tackling quite often difficult problems inspires you, then that's certainly something you should consider. So the road for innovation starts invariably at senior high school or the education between the ages of 16 and 18. And international education for those year groups focuses mainly on three main paths. So one is A-level, and that is the route of preference for the UK. So in A-level, students tend to do a small number of very detailed subjects. So if you want to study physics or engineering, you probably do chemistry, maths, further maths and physics at A-level, but certainly no more than 4. I think on average, students do 3.3 A-levels. Then there's the American system, which is the AP system, and that prepares you specifically for study at US universities. And APs tend not to have the depth of A-level subjects, but students tend to do more than 3 or 4, so sometimes 5 or 6. So straight away, we're looking at very different educational systems. So one has depth but not breadth, the other has breadth but not depth. Which is right? Probably neither. So I'm not advocating for one or the other, just making you aware that they're different routes. So A-level will give you that detailed technical knowledge at an early age, but it won't broaden your horizons. AP won't give you that detailed technical knowledge to the level that A-level will, but you will have a greater breadth of subjects, and therefore you might be able to choose better which fields you want to study in the long term. Of course, then there's the International Baccalaureate, and that's somewhere between the two. So it has 3 high subjects, which mirrors A-level, but then it has a breadth of standard subjects, which kind of mirrors AP. So IB is a compromise between the two. Whichever study field and system you're in, it makes no difference really to your long-term potential to innovate or be a researcher. So what I want to do is to talk about what I think the key elements of innovation are and what you need to be a good innovator. I will then talk about, when you actually get there, what will be expected of you. And I'll talk a little bit about the route on the way, which is quite important. So jumping a long way ahead now, what makes a good innovator? Well, I think there are 3 key things. I think the first thing is integrity. And by integrity, I mean somebody who is aware of a broad range of techniques at solving problems that are often quite challenging. And innovation is not about the ultimate solution to the ultimate problem. Innovation is looking at a problem and working out an effective way of solving that problem. It may be a non-ideal way, but as long as it solves the problem, then that's innovation. And a good example is, how do you design a bridge? Now, if a bridge fails in an ideal way, it will be a pile of powder on the floor, but bridges never fail like that. Either tension members break or compression members buckle. But it's identifying where those forces are going to be concentrated, optimizing the geometry of that particular member, and using just enough material so the bridge performs, i.e. it supports the weight that you want it to. It's not about the perfect solution. It's about a solution that works for that particular problem. And so innovators tend to be very practical people. If you're not practical, you will quite often come up with a solution that you can't implement. If you can't implement the solution, then there's no innovation. So it's about a practical awareness, bringing lots of different knowledge to one subject, combining that knowledge to produce something that's better than you had to begin with. And that roughly is innovation. Innovators need to be versatile. And unless you have a very narrow view on what you want to work on, and it might be an invention that you spend your lifetime developing, innovators are going to have to be broader than that. They're going to have to be versatile. They're going to have to see where the problems are in a way that you can't predict. And when you understand where the problems are, you bring different abilities to that problem to solve it. So it's not about somebody writing down now what you're going to be doing in your career as a researcher or as an innovator. It's about you being aware of where those opportunities arise, but equipping yourself with the ability to address those particular problems. The third thing is responsibility. Innovators have to take responsibility. It's not enough to invent something and to walk away. There are often consequences of all inventions, and innovators need to operate with great ethical awareness and be responsible for the outcomes for their innovations. In other words, that puts on a great deal of pressure and responsibility for innovators to behave appropriately, to behave honestly and with great integrity. So that's where you're going. What about the route to actually get there? Well, the route to get there can be quite involved. You're studying at school now, and that will then tell you whether you feel you have a flair for innovation, invention, research, but not absolutely, because you're on a journey that involves higher education, universities, probably some of the best universities around the world. And I notice from this particular establishment, you had a number of successful applicants at the University of Cambridge last year, and obviously the academic standards there are very high. But as you go along this route, you will make your mind up, you will decide where those opportunities are for you and what subjects are in and whether you want to take them or not. So it could be biochemistry, it could be engineering, it could be physics if there's a research orientation, but you don't have to make your mind up now. You know, there's not one box that you need to put yourself in. It's experiential, and your learning experiences will tell you where ultimately you want to go. So A-level, IB, and AP is really a period for you to decide where that interest lies. And do you feel a flair for solving technical and challenging problems? And if you do, then the chances are you're on the road to potential innovation. So what happens when you get to university? Well, the key thing is to choose the right subject. I often speak to students who've applied to the University of Cambridge just because it's Cambridge. That is not the right reason to choose a subject. You need to find a syllabus at a good university, and in the UK, we have 25 so-called Russell Group universities, excuse me, but you find the right subject. And if you find the right subject, you will thrive. Cambridge has very academic courses, and they're not for everybody. If there are some elements of practical innovation that you need to develop, then Cambridge might not be the best place for you. So do your research, make sure you get on the right course. When you're at university, it's an opportunity to learn the building blocks that you will then apply as an innovator or researcher. Quite often I speak to students and they seem obsessed with, what's the research component of the degree they're doing? Will I be doing research in my first year? Will I be doing research in my second year? What I say to all those students is very simple. There may be opportunities to get involved in research-related projects during your undergraduate course, and particularly in your final year, where typically 50% of your activity will be on a research project with an academic member of staff or even working in a research group. But the period you spend before that will be learning the mechanisms, the building blocks, the technical skills, either mathematics, applied science, whatever that may be, so that you will become an effective innovator and effective researcher. Doing research too early may not help you because you don't have the tools to actually deliver what you need to do as an effective researcher early on. So my recommendation is that for the early years at university, you just focus on learning whatever is on the syllabus of the course. You learn how to do the experiments, you learn how to record data, you learn how to report data, you learn how to communicate. And you put all these building blocks together, and then after maybe 1 or 2 years, you can then start thinking about, do I really want to do research and hence innovation? And then if you do, that will affect your final choice of project in your final year. But in the meantime, you can start thinking about, what do I do in the vacations? What do I do over the summer months? What about an internship in a laboratory at the university you're studying? What about an industrial internship? And industry research and innovation in industry is very different to that in universities. So in industry, obviously industry has to make a profit. If it doesn't make a profit, then it's not sustainable. So industry is very much driven by projects, and we have versatile researchers and technologists and innovators that move from project to project. And that depends where the funding source comes from. So 1 5-year period, you might be in one thing, another 5-year period, you might be doing another. Research and innovation at universities is different. So typically academics are given tenure. So it's the individual that's appointed to the retiring age. And at that point, the projects go with the individual. So hence I spent a career working on superconductivity. That wouldn't have happened in industry, because while I've acquired funding for my research from various research funding organizations, it's been up to me to get that money. It's not been a project that's given to me and that I need to deliver. So you need to understand the difference: innovation in industry, innovation in universities. And then there's private innovation. You could become an entrepreneur. It's quite difficult to get going, and I would recommend that you acquire experience from either an industry or a university before you do that, and that will equip you better for life. I wanted to mention a little bit about problem-based learning. So problem-based learning is effectively a new way of learning. Rather than you sit in front of a teacher and a teacher gives you solutions to problems, you write them up and then you do exams, and if you get the right answer, you get a mark. If you don't, you don't. Problem-based learning actually gives you a communal problem, and you work on the solutions with groups of people. So it could be global warming, and you and another 5 or 6 people in a team will look at different solutions to global warming, and they'll all be presented at the end. So you get a very broad range of the subject, the solutions that are available, and the impact those solutions will have. Not every school can offer problem-based learning, but it does help innovation in terms of understanding whether innovation's for you. So, what will you acquire? What are the key skills that you'll acquire on the road to deciding whether you want to be an innovator? Well, the first thing that you'll have to do will be to improvise. So quite often, you know what the solution is, but you either don't have the tools or the materials or the time to develop it. So you might need a second solution, and that ability to improvise is, a marked feature of most innovators. You'll need to collaborate. Very few innovators work on their own. If it's engineering, you'll need to talk to civil engineers, electrical engineers, manufacturing engineers. So don't think you're doing it on your own. You'll do a lot better if you work with others. And the final thing will be an ability to communicate. If you can't communicate your ideas, they may be the best ideas in the world, but nobody will ever know. So an ability to communicate fairly, to recognize sources of information you've used, and to state very clearly where you think the solution to a given problem or challenge lies. And if you can't do that, then nobody will know about your innovations. So to conclude, you're at a stage of your life that is very exciting. You've got a great adventure ahead of you. Use that adventure to understand more and more about the technical basis, the technical subject that relates to good innovation, and be honest with yourself along that journey. Is this something you want to do? Don't try to rush it. Don't think you've got to immerse yourself in research in term 1. Don't think you've got to go out and start up your own company while you're at university. Most students don't, and of those companies that are started, a huge number fail. It's much better to acquire those building blocks, acquire those skills, and then when you've mastered your art, you can then move on to innovation and research. So with that, I'd like to wish you all the very best of luck. I'm sure I'm talking to a number of students with extraordinary careers ahead of them. You know, the future is absolutely bright for you. The world is changing. We need bright young people to help us solve a myriad of problems that we have, and I don't need to tell you where they are. In other words, you know, the future of the world is on your shoulders, so no pressure, but enjoy every minute of it. Thank you and good luck. Bye-bye.